Okay, let's check out letters F and G. I might go ahead and throw H in there. I haven't decided yet. Let's see how long it takes. So lines are a significant portion of math. So remember, when you want to find a line, you want to start with the slopes, delta y over delta x. So notice from here to here, the y values drop 5, but the x values increase by 1. So there's my slope. And I chose this coordinate right here to do y minus the y value equals m. Remember, we do y minus y1 equals the slope times x minus x1. Now, this problem is kind of funny because we got our delta y over delta x, but we want to keep our wits about us because from here to here, we've definitely gone up 5, but down here we've dropped 2. So I've got a slope of negative 5/2. But the problem literally handed me that the y-intercept is 2. So I might as well just say negative 5/2 x plus 2. I mean, I could do point slope, but it's kind of silly to write down, because x minus the x value, it's x minus 0, which is just x. I mean, it's just silly to do that. Last one over here, what I see is that delta y over delta x appears to be, I'm going up 5 and I'm going down 1. So negative 5. Again, not a hard problem, but I think I would still probably go y minus the y value, x minus the x value, and throw a slope in front of negative 5. And of course, if you really wanted to, there'd be no problem with using a little distributive property and calling this one y equals negative 5x minus 20, but bring the 2 across, and we got minus 18. But honestly, this is an easier thing to look at because who the heck wants to go down and find negative 18 and use that as your starting value for your y-intercept? Okay, now, for letter G, we're getting into finding and graphing inverses. So this is a little trickier. So the first thing is that they're asking a question if they are in fact inverses. So if that is true, if I took f of g, in other words, take f, which is x cubed minus 1, and I replaced it with g inside, if I cube the cube root, I get x plus 1 minus 1, which is in fact x. That confirms 100% that they are in fact inverses of each other because they undo each other. That's perfectly. That is the definition of an inverse, is if you have f of g of x or g of f of x, and it's 1x. Now here, if we're finding the equation of that inverse, we start by swapping x and y like that. We do a little quick arithmetic on that, moving things around because I want to get y by itself. I'm going to do this in 2 steps because I don't like the fraction. So I'm going to multiply everybody by 3. And the last thing I'm going to do is I'm going to divide by negative 2. So when I divide by negative 2, y will be all by itself, but I'm going to rename it f inverse to honor where it came from. But again, I divided everything by negative 2. And so this is what I see. That would be the inverse function of that f. And keep in mind, if we made up a number like 9, negative 2 times 9 over 3 would be negative 6, plus 5 is negative 1. If I came down here and I plugged in negative 1, I'd get positive 3 halves plus 15 halves, which is 18 halves, and I got the 9 right back. So that's a thing that you can do to quickly check a little bit, plug a number into the original, and then take that new number and see if you get your original back. Now, the last one is down here where we're just looking. And so sometimes people think f of g is the same as g of f, but I think you guys know better. So remember, g of 2 literally says, let's plug 2 into the original function. So g of 2 would be 3 over 1. And this says, let's take that f and plug it in. So f of g of 2 is really just f of 3. And if we plugged in 3, I'd get 9 minus 1, which is 8. So that's that first problem. Now, g of f of 2 simply says, well, let's go find f of 2. And f of 2 would be 4 minus 1, which is 3. And then we're going to find g of f of 2, which is just saying, let's find g of 3. And of course, if I plug 3 in up here, I would get 3 plus 1, which is 4. Over 3 minus 1, which is 2. And so I got 2. F of 2 just means plug f of 2 in, which gave me 3. So f of 2 is just f of 3. And f of 3, of course, is just plugging in here, which is 9 minus 1, which is 8. So we know that is the rest of G. And let's see if we have enough time to maybe do a little teeny bit of this one. Okay. When is the cosine negative? Well, ASTC, we know the cosine should be negative in these two quadrants. I personally know that the cosine is negative whenever you're dealing with some kind of or it should be √3/2, I should say, at some kind of a pi over 6. So the 2 pi over 6 is over here to the left, or 5 and 7. And what more can I say? I'm done. Now over here, there's something else at play, and that is we've got a mixture of sines and cosines. So I want to remind you that sine squared plus cosine squared is 1. So if I could replace this cosine squared with a 1 minus sine squared, we've done this exact problem over the last year a couple of times. Now we're speaking purely in the language of sines. I'm going to do just a little distributive property. And I'm going to divide everything by a negative so I can make this look a little bit better. And if I brought that across, it's going to be a 1. And so now we can factor this because 2 sine squared is 2 sine times sine. The number 1 clearly has to be some 1s. A little bit of a process here, but 2 sine squared, 2 sine and a 1 sine would be sine. Looks pretty good. So this problem is really asking me, when is the sine 1/2 or when is the sine -1? And this one happens at 3 pi over 2. That's when on the unit circle it's straight down. And the sine is 1/2 at pi over 6s, but I need the 2 where the sine is positive, so 1 and 5 does it. And that will be the end of that video, and I'll be back for whatever heck number the next one is called, because the phrasing is kind of weird. All right, see you back. Bye-bye.